Hello everyone, welcome to the today's post content discussion of the LeetCode contest. Today we will be discussing the solution for the problem 123. We will be discussing intuition of the solution, and today's contest is slightly easier side, and it's not much difficult. So let's start with the first question. So the first question is completely based on the observation based. So you need to observe based by taking few test cases. So let's see the first question. So this is the first question, minimum operations required to equalize array. So you are given an integer array nums of length n. In an operation, choose any subarray of length from L to R. So that might be from the 0 to n minus 1 and replace each element in that subarray with the bitwise and of all elements. So return the minimum number of operations required to make all elements equal. A subarray is a contiguous non-empty sequence of elements within an array. So I think it's clear. The subarray is the contiguous part of the array, and yeah, let's discuss few test case here. So I will be taking the test, one of the test case here. Yeah, this is the one test case I will be taking. So what you can do is you can choose any subarray, like this is a subarray, and this is also a subarray, and this is also subarray. So you need to perform the AND operation on the all the elements. Let's say, so I will be taking one of the subarray from this one. So what I can do is that I will be take the one of subarray, that is yeah, I will be take this subarray. Let's take that subarray. So the elements in the subarray are 1 2 3. So if I write the all the binary representation of the all the elements, so it would be look like something 0 0, yeah, sorry, 1 0. So 0 1 1. So if I do AND operation, AND is when the any bit is unset, then the complete result is not set, right? Let's say this is an unset bit and this is a set bit, so you will find 0. So let's say this is an 0, you will find 0. So 1 and 1, so if both bits are set, then you will be having set bit, otherwise you will be having unset bit, that means 0. And there is another yeah, that it's same as it is. So if you find two bits are set bits, so then you will find the result bit should be set, otherwise you will find 0. This is a simple and table, I would say. So yeah, it's, I think it's known to everyone. So when I will do and of all these elements 1 0, so I found one of the 0 here, so the complete result will mm, boil down to the 0 here. So if you can see the second bits, so I found one of the 0 here. So if I do and of 0 and 1 and 1, so I will definitely get a result of 0, because I found one of the bit is 0. So 0 0. So at the last the result is 0. So what I can do is that I will be replace all these subarray elements to be 0. So I need to perform like any number of operations, minimum number of operations, not any number of operations, such that I can have the complete array should be equal to some element as x. So I need to have this, right? So what I can do is that if you can observe that so let me erase it out. So what you can observe is that if I select this the complete array, let's I will take L is equal to 0 and R is equal to n minus 1. So this is one, I can have the complete array equal to the sum element of x. If I do and between the L to 0 to R of R is equal to n minus 1, so I will be having answer as something and of all these elements, right? So I will be replace all this element with this and, so that is the one operation required to make the complete array equal to some element x, right? So what I can do is that so let's say there is some case that which what happens if the all the elements in the array are equal. So then we require zero operation, because the elements are already equal, then we no need to perform any operations. So what if the arrays all the elements in the array are not equal? So there is only one operation required, that what I will select is I will select L is equal to 0 and R is equal to n minus 1, and I will be traversing completely from I is equal to 0 to I is less than n minus, yeah, I is less than n, I plus plus. So in this what I'm doing is I will be doing and of taking and of all the elements. So answer and of array of I, right? So I will be returning it out answer. So after getting the and of all these elements, I would having some element x. So I will replace all this complete array, all the elements with the x. So then I would say that the array is equalized. This is a basic observation based question, right? So let's see the code once. Yeah, you can see that I will be taking flag here true because I need to check that all the elements are equal or not. So there are many ways to check that all elements equal or not. So I will be using the flag here, so to check that the elements are is the array is having all the same elements or not. So after that I will be simply taking, so in answer I will be taking my first element. So after that I will be calculating the result from the index is equal, I is equal to 1. I will be storing into that into answer. And you can see that I will be replacing yeah, I will be replacing all these array elements with the and of all these elements. I think we don't need to calculate and also. We need to just check that this array is having all the equal elements, then return 0, otherwise return 1. There is a simple thing you can do. Yeah, that's all about the first question. Let's go for the second question. The second question is based on some simulations and observation based. So it's also very a standard problem and it's not much difficult. So if you can observe few test cases and after some observations, you can find some solution. So let's see the question. So the question is minimum operations to transform the string. So you are given a string as consisting only lowercase English letters. You can perform the following operations any number of times, including 0. Choose any character C in the string and replace every occurrence of C with the next lowercase letters in the English alphabet. Return the minimum number of operations required to transform a string S into a string consisting of only a characters. So at the last, after performing the minimum number of any number of operations, so the actual result is look like something like that. The string is completely having only characters A, right? So we need to transform all the characters which are not equal to A to the equal to A. So yeah, let's discuss this test cases here. So the question is saying that I will be given a string. Sorry. So we will be given a string. Let's say string str is equal to, so str is equal to, yeah, that is the string A B C D, right? So the question is saying that you can select any character from the string. So you can select B, you can select C, you can select D, you can select T. So you need to perform minimum number of operations such that so all these characters should be equal to A. So the operation is saying that if you select B, so it can be replaced with the next character, that means C. So if you select C, so C can be replaced with D. So like that the Z can be replaced with A. So we need to reach to A. So after the performing these operations, so if you can observe that yeah, we'll do some you can see that the operation required to perform, yeah, this, let's take this test case here. So yeah, let's say I will be taking B here. So when I am taking B, I need to definitely change it to C, right, to get to go forward. So anyhow we need to reach at the Z, so that only we can actually go to the A. Yeah, so I can select to C. So after performing this operation, the string is look like something. So let me draw the, so I will be taking B here. So it would be changing to C. B is changed to C. Yeah, B is equal to C. Then the string is look like something A C C D. So you can see now that the string has modified little bit, so that it's required less number of operations in the next step if you choose the character C here. So what if I am doing is I will be choose the character C here. So if you select this character C, so you can change all the characters C in the complete string. Let's say I will be having C here. So if I select C here, you can change all the characters C here. So that's the question is saying. So let's see. So if I select C, so what is the next character for the C? It will be definitely D, right? So you can see that this is a this is one operation. So in the next operation, I will be taking C here. So the C, the next character is D. So the resulting string would be look like something A D E D and yeah, D E, right. So in the next step, what I can do is that I will be choose D. So I will be make it as this is one operation. So D is the next character is E. So the resultant string would be look like something E, right? So you can see that we got one of the similar string, right? So the complete string is same. Yeah, these all characters are same. What I can do is that if I want to transfer this all the characters into Z, so what is the operations required? If you can see that numbering from the A at the 0, B at the 1, yeah, you can go on numbering like 2, 3, 4, 5, right? So if you see that C 4, so there are 26 characters. So if I go for the Z, so Z is represented by 25 the index. So I will be taking 0 based indexing. So it is a 26 character. This is a first character, right? So according to that one base indexing. So if I want to number of operations required to change all these E characters into the Z characters, what is it? So if I select E, so I can change all the characters which is equal to all the characters of E, right? So I can select, so this E can change. So if I change all, if I select E, so I can change all the equal characters to E to the next character. So what is the operations required? So the next step you would be change E to the F, right? So in the next step what you can do is F should be changed to E, F, G, right? So the G is changed to H. So it will be go on changing, like it will be required one operation, it will be required one operation. So after the resulting string would be like look like something like D, F, F, right? So yeah, D, G, yeah, sorry, should be E, A, right? So A, F, J, A. So the next operation it would be look like something, right? So yeah, it's basically like if you know the last character, so that is 25, and this is at the particular, let's see, yeah. So if you want to go from E to the Z, so what is the, what how many number of operations you would see here, that so it would definitely like 25 minus, so this I'm taking 0 base indexing here. So yeah, if you you need to use the 26 minus the particular index like 4. So there would be something like 26 minus 4 means yeah, 22 operations required to change this particular this string A to something A, right? So after 22 operations, the resultant string should be look like something. This is actually we want, right? Yeah, you need to observe something that let's take YZ here, right? So I can change Y to the next character, that is Z here. You can say Z. So what I can doing is I will be change both character to A in that one step. Yeah, let's take some of the example to observe the what happening in this case. So A, C, C, F, G, H, right? So if you want to change this string to be has something like in this, right? So you want to change this string to completely to this, all the characters should be equal to A. So what I'm doing is that I don't want to disturb these characters, so I'm just want to focus on the characters which are not equal to A, right? So if I select this C, so what I can do is C. So I will definitely change this all the characters of C to the D, right? Next character. So this would be changed to DD. So yeah, the resulting, so if I will change C is equal to D, so it would look something like E, F, G, H, right? So in the next character, in the next iteration, you would see that so, so I will be replacing D with the E, A, D, sorry, E, F, G, H, right? So in the next, I will be replace E with F, right? That would be look something like A. Um, yeah, it would be F, you can observe one thing that now, so you saw that E when C has reached to the F, that is the next, the not similar character, that is F. So this has merged, f is merged into the yeah, c is came to the f. So in the after few steps the f might be go to the g, right? So the g might be go to the h, and the h might be go to the z, right? So what I'm doing is that I will be taking the yeah. So if I want to make c to z, so I will be definitely require 26 minus, yeah, yeah, it would be 2, right? That is 24 steps, right? Yeah, you can see that where I wrote, yeah, c2 26 characters means the z is 26 characters. So z minus the particular character which c is standing at. So we'll require 24 steps to reach the a, right? After that, the all the characters which is along with the c, they will must reach at the a, right? Yeah, you can observe that. So initially there are two c's, but after when c has changed to f, so f is got merged into the this team, right? So again the same thing will be happen, like when I'm choosing these three f's, so these three f might must be changed to g. So in the next step you might see that this would be looks like something like g g g. You can see that this character has got into this one. So you can see this is one operations. So this is the one set of characters which you actually need to go for the next step. So in the next step you would definitely see that the characters which are not similar, that must be merged into this one. So that would be g, yeah, g is changed into h, right? So in the next step, so h, you might see that. So these all the characters have changed to some of the similar characters. So what I can do is that I will be find simple that. So h, if you want to reach the h to the a, so if you want to reach to the a, so there you must to do the 26 minus h, index of the h, right? So you will definitely find the number of steps to reach a. So the at the last the observation is that observation is select the character, select the character which is farther farther from um, z, right? So which is far away from z, so please try to select the element which is most far from the z. Like it means that I will be having string a, c, d, y, x, x, z, right? So what I'm doing is that we will be selecting the element which is far from z. So if you take from z, so don't disturb this a, so we don't want to change it to this. So let's take instead of except a, so you need to take from this array, from this string. So what you can do is that from this substring you can take that the element which is the character which is more far from the z, like that is that absolutely c, right? We can see that c is the very far from the z, so d is not. So you can select this such element. So you need to select such element that is more farther from the z, and so that would be the by selecting that element. So if you calculate the z minus the farthest farthest element index, farthest element index, yeah, that is 26. So what we can do is that we'll be traversing the complete string, right? So there would be 26 characters. I will be storing the all the yeah, I will be storing the frequency or the true, or you can mark the characters. So the which are characters are present in the string or which are not. So I will be marking all the characters into the my 26 size character array. So yeah, I will be simulating for these 26 characters from I is equal to 0 to I less than 20 6. So what I'm doing is that I just want to find the character which is far from the 26. Yeah, that is z, right? So yeah, I will be selecting some like max. Yeah, sorry. So what I'm selecting, this answer is equal to max of answer comma 26 minus yeah, the present if if the present character, that is a, is present in this string, then only I will select that particular character, right? So let's see that I will be having a z, sorry, the when we are selecting a, we don't want to select a because, so we'll see how we can actually eliminate that a. So 20, yeah, a z, z, sorry. So I will be taking like a, b, d, y, y, z, right? So what I'm doing is that I will be selecting the character which is far from the z. So you can see the far character is b, so we are not taking the a because it's not creating, it's not required here. So I will be taking the far character for the z is, that is b, right? So what does it happening is that when you are selecting b here, so you are changing it to c. So all the characters which are present, which are equal to c, they are merging into these groups. Again, when you are changing c to d, so all the characters of the d, so change it to the e. So after this operation, the characters, all the characters which are present E, so will be changed to the F, right? So at the last, the complete all the characters are merged into the single group, so you can actually change it to Z. So what I'm doing is that I will be just finding the characters which is far. So if I know this is a farthest character from Z, so I will definitely say that this many number of operations um, required to change all the elements equal to A, right? So yeah, that is, this is what this actually storing, that is maximum of the the character which is maximum far from the at the maximum distance from the jet. So I will be taking that one. So let's see the code ones. So yeah, I think this is not, the storing frequency is not creating any impact here. So you can see that it's not required, I would say. So you can mark using true or false also, but yeah, it's, yeah, in the contest I did this one. So you can see that I will be marking all the characters, 26 characters, and I will be simply traversing all the 26 characters. What I'm doing is that I will be taking the distance between the particular character to z, right? Let's say there is some character, you can see that I will be taking some a, b, d, g, h, right? So what I'm doing is that I will be traversing this string, and I will be storing the distance between the z, that is 26 minus the particular index of the character. So I am stored in the 1 to 25. So a here, z here. So I will be simply, if I do 26 minus the index of the particular character, I will get the distance between the um, character to z, right? So that I need to maximum, that I want maximum. So that I would say that that would be the minimum number of operations to make that complete string to equal to a. Yeah, you can see that after, when if we only taking the distance when it's there's the particular character is present in the string, so otherwise we don't want to include that one. So the frequency of greater than 0, it means that the particular character is present in the string, then only I will be adding the distance between the particular character to the z, and I will be returning that answer. Yeah, it's all about the second question. Now we will be solving the problem 3. So let's see that yeah, the problem 3 is based on the next greater element, and the next greater element, if you know that, um, if you know the stack data structure, so you can actually implement it very simply. So little implementation, and yeah, you will be find some implementation here, and you should know the next greater element and previous, how we can actually find the next greater element and previous greater element. That's completely uses of the stack data structure here. So let's see the question once. So the question is that count bowl subarrays. So you are given an integer array nums with distinct elements. A subarray of nums L2 R of nums is called a bowl if the subarray has length at least 3, that is r minus l plus 1 is greater than equal to 3. Minimum of its two index is minimum of two ends is strictly greater than the maximum of all the elements between that is L to R, L minus 1 to the R minus yeah, L plus 1 to the R minus 1. So I will be explaining how the execution. So what is the question is saying that so the question is that I will be taking some array here. Let's take 5, 1, 2, 3, 6 here. So what you can do is that you need to select any subarray of size 3. Yeah, at least it should be size 3. It might be greater than size 3. So it might be look like something, it might be look like something. Yeah, it might be something. So the condition is that when you are selecting any subarray of length greater than or equal to 3, so let's say this is an starting and this is an ending. So this is a size 3, right? What the condition is that, so the minimum of array of L and array of R should be greater than, yeah, they should be greater than, so max of all the elements present in between these two ranges. That means that all the elements between the array of L plus 1 2, so array of R minus 1, right? So I will explain. So L plus 1 means this index, R minus 1 means this index. So it should, so any of this minimum of this these two elements, so 2, so minimum of this 5 and 2 is 2, should be greater than maximum of all maximum of all the elements present in between. So max of element that is present in between this range, so it should be less than this element, right? Let's say, yeah, this is 1. So you can see maximum element between this range is 1. So this condition should be followed. So if it's followed, then you can increase your answer plus plus. That means it is a valid subarray that you have actually found. Yeah, let's take some test case from the question itself. So I will be taking some test case from the question itself. So you can see that, yeah, I will be take this test case here. 25314. Yeah. So what I can do is take is that 25143, right? So let me write it clearly. 25134. So initially, the main goal is to find the value. Yeah, main goal is to find the subarray that should be greater than or equal to 3, right? So if you are standing at this point, and if you are standing at this point, you find this is subarray which is greater than or equal to 3 size. This is 3 size, right? So the minimum of these two elements, this is an L and this is a minimum of these two element is 1, so it should be greater than maximum of any all the elements between this range, so that is 5. So it's false, so it is not a valid subarray. So what I can do is that I can increase my pointer. So I can come to here. So again it's not a valid because you can see that this this element is greater than this two of these elements. Minimum of it means that is 2. So the valid window I would find is that the valid window is that when I come earlier, so when my R is here, or what else that so when R is here, right? So let's see. So in this case, you can see that the minimum of this L and R is 3. It should be greater than the maximum all the elements between this range. So that is 1. So it is true. Then we'll increase our answer. So in the next test case, what we'll do is we'll try to find the um, more answers. So I will be increase my point my R here. So you can see that the minimum of these two elements, that is 5 and 4. So the minimum of the 5 and 4 is something, yeah, 4. That should be greater than, yeah, maximum of all this array, that is 3. So it is true. So answer plus plus. So we found there are two subarrays like 513 5134 which satisfy the condition, right? Yeah, let's observe something, right? We'll take some second test case. Yeah, that is 51234. So test case is 5 1 2 3 4, right? So yeah, you can see that the main goal is to take any element. So the particular element should definitely have any of the greater element previously or any of the greater element at the next, right? Then we would definitely say that it should be uh, forming one subarray which is greater than equal to 3. And you can see that let's see here. Let's see. I would say this is one subarray, right? And this is one subarray. This is one subarray, right? There are three subarray valid subarrays: 5 1 2, 5 1 2 3. So 5 1 2 3 4. So let's do some simulations here so that it's very clear that what you are doing is that if you select this subarray, first subarray, so the minimum, it means that 2 comma 5 should be greater than, so max of 1, that is there is only one element, right? So minimum is 2, 2 greater than 1, true, right? When you are going to next test case, let's see that. So in the next test case we are finding minimum of, so we got increased our window, that should be size 4. Yeah, the minimum of 5 comma 3, so it should be greater than max of 1 comma 2, right? Yeah, that is 3 is greater than 2. Again we found the valid one. So when we go for the third window, that is length 5, we can see that this is an L. So now the L is here, R is here, and we can see that minimum of 5 comma 4 should be greater than max of 1 comma 2 comma 3, right? And you can see that 4 is greater than 3. So there is a simple observation is that instead of going for the each window and finding the maximum and reading all those things, so you can observe, we will observe one thing here. So what we will do is that we will select the particular element which can actually form the subarray, right? So yeah, I will be taking this element. So this element never forms a subarray which is greater than equal to 3 by according to this condition, because this is a first element, so this don't have any left elements, so it will not form any subarray. So what I am doing is I will be selecting the element at the index 1. So if I select this element, I want any element which is previously greater. So I want any element which is next greater. Then I would definitely say that this element is forming one subarray that is satisfying the conditions, right? So the condition is simply that the the middle element should be less than any of the element, right? So if the particular element is having any previous greater element and any next greater element, then I would definitely say that this element is definitely forming one subarray. So when I'm going for the next element, you can see that so when I'm going for the 2, so I would definitely say that if it is having any previous greater element, so it is having 5. So if it is having next greater element, it is having 3. So I would definitely say that I can form 5. Yeah, that initially was 5 1 2. So then this look like something like 5 1 2 3, right? So yeah, this one is valid. So when I'm going for this element, I'm asking this element, do you have any previous greater elements and do you have any um, next greater elements? So it should definitely have previous greater and next greater. Then only it's possible that then only I would say this should be the less than minimum of these two elements. So I found that this, so I'm having next greater and previous greater, that is 5 1 2 3 4. This is a valid subarray, right? So I found three subarrays that should be valid. So the main idea is to that we will be go on checking. So for each index, so the, the code is look like something like for each index, what we'll do is for each index find next greater element and previous greater element, right? So after finding these two things, so we will be simulate from for I is equal to 1 and I is less than n minus 1, because we don't want to reach this element because it don't have any next greater elements. So we actually terminate our loop here. So I will be traversing from I is equal to 1 to the I is less than n minus 1. So for each I will be finding that do you have any previous greater element or do you have any next greater element. So if the I is having next greater element and I is having previous greater element, then I will be simply increment my answer here, right? So yeah, this is a simple iteration at the last you can do. So for the next greater element and previous greater element, you can do one thing that you need to definitely know the stack data structure. So that will be these are the very famous standard questions that you definitely need to solve. So if you don't know about this, please try to solve before solving this question. After you, if you're able to solve these two things, then it's a super simple. And let's see one answer. You can see that initially I will be finding declaring two vectors that will be storing the for the this vector is storing the next greater element, this vector is storing the previous greater element, right? So what I'm doing is that I will be using stack, I will be finding the next greater element in here. So I will be empty the stack to reuse it again, and I will be finding the previous greater element using this loop. And at the last, what I'm doing is that for each index from I is equal to 1 to n minus 1, do you have, it should be definitely have previous greater and next greater. Then I would definitely say that it would be forming some subarray which is greater than or equal to length 3. Then I will be returning the answer here. So if you can see the time complexity of this question, yeah, it would be, so I will be running big O of n here. So this is not a, I would say, this not running completely for the, don't see that by seeing this inside for loop, don't think that it should be of n square. It's not like, not doing that one. So at the worst case they are going in the big O of n only. Yeah, this is a big O of n, right? So at the last, yeah, big O of 3n means at most at the last the time total time complexity will look like something big O of n only, big O of 3n. But you can remove the constant, you will definitely find the big O of n. So if you can go for the space complexity, we are using two vectors here. So that is n one stack. So at most the stack is storing the n elements, so they are storing n elements. That space complexity is something 3n, but I would say that it would be, if you can remove the three constants, space complexity would be big O of n only. So the space, the time complexity would be also big O of n, right? So yeah, this is our time complexities. So if you can see in the previous questions, the time complexity is big O. In the second question, that is character. So in the second question, we are only traversing from the 1 to 26. That is the time complexity is constant. That is 1 to power 20, big O of 25, and we are taking container of 25 size. So this is the time complexity for the second question, space complex for the second question. And in the first question, we saw that we are only traversing from 0 to n, that is big O of n. We are not using any space there. So that is a constant space using in the first question, right? This is space complexity. Yeah, this is all about the today's contest. Thank you everyone.